Well, hello and welcome to Chapter 9, which is transport layer, one of the layers of the OSI model. It's very important. So we can have an idea about what is the OSI, what is the transport layer, what is the function of the transport layer, and we will identify some protocols that work at this layer and how what is the difference between them. All right. All right, transport layers. Well, one of the many functions of transport layer is tracking the conversation between remote computers, all right? And I'll come back to this one. Segmentations and identify the application. Needless to know that users and computers both of them are multitasking. So looking at this computer right here, he's running a group of applications at exactly the same time. He's stream video, looks to me like he's a teenager. He's a stream video, he's online chatting, he's on multiple pages, probably Facebook, probably YouTube, instant messaging, all this at exactly the same time. Now, I want you to think with me, imagine how your computer or a server that is handling thousands and thousands of multiple applications, how would he track them? How would he know which one is for what computer? Well, this is where exactly TCP comes in handy. TCP comes in handy to track what applications belong to what client, even though you have thousands of them, right? Next thing is segmentations. Needless to tell you that videos and messages and audio and video messages are very large in their frame. So as a result, if you send an entire message one shot, will take a minute or two before that message is done. So what is the solution? So in order not for a single computer to hog and use all the bandwidth, the transport layer will take that message and break it into multiple segments, then send one segment at a time. By doing so, the transport layer will allow other computers to use the same network. Finally, one of the other things that happen at transport layer, identify the application. It ensures that even with multiple applications running, all applications receive the correct data via port number. It assigns a port number at every single application. For instance, as if you remember, we talked about a network layer. And if you recall, network layer identifies machines by using IP addresses. We talked about data link layer. We said data link layer identify client by using MAC addresses. Well, a transport layer uses a port number. For instance, as you can see, HTTP uses port 80, SSH uses port 22, and so on. So it is the transport layer that assigns a port number to every single application. As a matter of fact, no two applications in TCP/IP use the same port number. All right, moving to the next one. In here, they're showing us one of the other feature that built in what do you call it, in a transport layer. In transport layer, you can see transport layer. Here's a TCP and UDP is for instance dependent on the protocol that you're using. In this case, TCP. All right, TCP and UDP are two protocols that work at the transport layers. All right, and what happened at transport layer, especially with TCP, it adds something known as reliability. It makes sure it does its best to make sure that the packet reach its destination. So reliability, it's take place at the transport. So a reliability here, especially for TCP, takes place over here. So there are additional field and acknowledgement and techniques and method that TCP uses to make sure that data are being delivered to where they supposed to go to. All right, TCP also starts something that is well known for hackers. Hackers understand this concept and is known as TCP Handshake. TCP Handshake. I really think about it. It's similar to human when you meet your friend for the first time. You're going to say, hello, hi John, what's up, how are you? This is you establishing what we call TCP handshaking. You don't start and asking him questions about how is his class or how is he doing without really saying hello, hi, how are you? So that hello, hi, how are you in computer language in the TCP IP is known as handshaking. So in handshaking, two computers using a TCP and the transport layer will decide either to start, when to start, and how to communicate. They will agree in a lot of stuff as we go. A lot of stuff. For instance, the compression, the encryption, the speed, the window, the sequence. There are 100 of other things that are defined by TCP IP before communication even take place. All right. Now, we said that TCP is very reliable, all right, and it does its best, and usually it makes a pretty job. But another protocol that also works at a transport layer is known as UDP. And just a quick idea, more details is coming. Unlike TCP, UDP, that is best effort. There is no guarantee. You remember that TCP is reliable and guarantees, while UDP does not. TCP has acknowledgement. It sends something to someone, say, hey, did you receive it? Yeah. Did you? Please let me know if you didn't receive it, so I'll send it back. UDP does not do that. All right. And those are two, if you want, similar to non-registered letters. That's what example. The example that I gave my student is two kids that delivers newspaper. One, his name is UDP, and one, his name is TCP. The TCP gets off its bike and go to the door and drop the paper right by the door. The UDP does not get off his bike. He just throws the newspaper. It comes by the door or not, that's not his problem. Now, here quickly, here's some comparison between TCP and UDP, and I want you to remember this. By the way, you may say, oh, you know that since TCP is more reliable and guaranteed, then we need to use it all the time. It's not up to us. It is the application that define, not the user. It is the application that define what transport protocol it uses. Different type of applications will use different type of protocol. So watch with me here. I want to put them side by side. Here is a UDP. UDP is used for IP telephony and stream live video. In other words, UDP is used from time-sensitive data, such as video streaming. For instance, when you are watching, for instance, Netflix, I'll guarantee you that that stream is coming to you over UDPs. When you are doing some kind of chatting online, such as using Skype or using any other, I'll guarantee you also that transport protocol that is being used is also UDP. Now, TCP, when you are browsing the internet, when you are sending emails, or when you're doing other things in the internet that are not time sensitive, you'll be using TCP as a transport protocol. Watching over here, here's some extra stuff, extra thing that you need to know. Obviously, since UDP is not reliable, does not guarantee, does not send what they call it. Remember the kid that I told you. So as a result, it is much faster. It's low overhead. When we look at its packet, as you can see it's much smaller than we compare it to TCP. Does not resend lost data. You get it or not, too bad. See you another time. Errors, if they happen, is not my problem. Is the application's problem. Delivers data as it arrives. Does not hold to it. As soon as it gets it, it delivers it. Right? There is no labeling. There is no sequencing. There is no order. There is nothing. If you are the first, but you come the last, it will send you as the last one anyway. Now, quickly looking at TCP, you can see here TCP is more reliable. It uses acknowledgements. We said that resend packet if data is lost, goes, oh, I'm sorry, I'll send it back to you. Again, think about the kid on the bike. He'll put the newspaper right by the door, and if it's not really right there, he goes back and put it right by the door. Delivers data in sequence. All the data they send, it's sent it in sequence, in numbers. As a matter of fact, think about UDP as your friend sending you a puzzle, very hard puzzle, that is not numbered or has no shape and it's very hard to put together. Think of TCP as a puzzle that is numbered and ordered and it's easy to put together, once it gets to the destination. I'll repeat before I move. It is not the end user that defines what kind of transport protocol to use. It is not the end user that will decide, I'm going to use UDP, now I'm going to use TCP. It is the application job that to choose that. All right. A little bit more information. I know I said that couple things over here, so you can see that TCP is known as connection oriented. Another way, it does not start sending information or data or packet till it makes sure that the other person is listening and a connection has been established. TCP ensures the application is ready to receive the data. It's again almost like you about to throw something to your friend, and he goes, "Hey Joe, are you ready?" They's coming. Then you throw the ball. This is TCP. UDP does not. TCP negotiates the amount of traffic that can be forwarded. TCP using something known as windowing, it'll ask the other computer, "Hey, how much can you handle at once?" And that computer may say 8 bytes. 10 bytes, 16 bytes, 4 bytes, and it sends exactly what that computer. So it does not overwhelm the other. Next thing, reliability. TCP ensures that each segment that the source sends arrives to its destination. Well, how does it do that? It go and ask, did you get it? Did you receive it? If you didn't, please let me know. I can send it back. All right. So this is a same order delivery in order 1, 2, 3, 4, 5. So to send. TCP use something known as numbering and sequencing to guarantee an ease and speed of assembly. TCP also use something known as a flow control, which is regulate the amount of data it sends. They define how much you can handle and only sends you that. I want you to look at, this is a header, this is a TCP header, and some of the feature that we talked about before, you're going to see it right here. For instance, I want you to see over here, here is a sequence number. First of all, here is a source and a destination. Here's a sequence number, all right? Here is an acknowledgement number, all right, right? And here is a checksum error, an error happened, it send it, okay? So all these are built in, what do you call it, in a TCP header, all right? We're going to talk more about them later. You're going to see later, all right? You're going to see later when we talk about the UDP. UDP does not support those, okay? Here is UDP. Very small, look. TCP, very large, 20 byte. UDP, very tiny and very small, all right? And a lot of features that we saw there are not here, including the sequences, the windows, the acknowledgement. They're missing, they're not here. All right, moving down. It is very important to understand that both TCP and UDP uses something known as a port number. A port number is used by the transport layer to identify the type of application that is being used. For instance, when we're using POP3, we're going to use a port 110. When we use HTTP, we use port 80. When we use internet chats as AIM, we use 531. When we use encrypted HTTP, we use 443. When we use Telnet, we use 21, and that's how it works. So transport layer uses TCP and UDP, which use a port number to identify the application that is running. All right. Here is what you need to know, that out there, this is all the ports that are in what you call it in the TCP IP support, right? TCP IP protocols, and from 0 to 23 are known as the well-known port. The recent port that I spoke about, like port 80, 21, 443, all those are known as well-known port, and they're default. A lot of times they stay the same and they don't change, and a lot of times are used by the servers that host the application. A web server, for instance, would use a port 80 to accept HTTP communications. Here is other port. There is 1024 to 49,151, and there is even more port that we don't use. But I want you to remember, the most important thing you need to remember is the following: 0 to 1024, which make 1024 known as default, known as well-known port. As a matter of fact, you can't be a computer technician or cybersecurity without knowing at least the first 20 port by heart. And here they come. You need to know this port by heart. You need to know all this port and what uses them. And here's what's going to make sense. For instance, port 20 and 21 is used by FTP, all right? 22 is used by SSH. I'll move on. 68 DHCP. You notice that every major application has a dedicated port, and that's what the transport protocol uses to identify and handle those applications. So I'm going to stop here. I'm going to start the second part of the lecture.